Welcome student. Welcome to my channel Talking Physics with Pias. So in the previous day we shall talk about the electric lines of force and its properties. So today we shall learn about the how to find out the electric field inside any closed surface. The surface may be cylindrical, the surface may be spherical or so on. So at first we go with derivation of the electric field and any closed surface. This is the consequence of a great theorem in electrostatics, which is called Gauss theorem. Now, before we reach to the Gauss theorem, we have considered some case. One is area vector. What is area vector? And what is the Gaussian surface? Number one is area vector. Number two is Gaussian surface. So, before now, we shall deal with only the magnitude of any surface area. So, if anyone said us to find the direction of area, any direction of any area, then if we take a surface S, then it will be a collection of a very small element ds over all it. So, the area vector, the magnitude of area vector is always directed normal to it. So, the direction of area ds is called area vector ds vector, which is acted upon normally to it. And also, the direction of area vector is denoted by n cap, which is normal to it. N cap is normal to it. Now, if we shall consider the electric field, now we consider the electric field along this, making an angle theta with the area vector. The area vector, this is the small area ds, and the area vector, that is ds vector, is acted upon normally to this area. If we take a small area in this, and if E, that is the electric field, makes an angle theta with the direction of area vector, then we can consider the normal component of E along ds, that is said to E cos theta into ds. This gives the electric flux. So electric flux phi equal to E ds cos theta, or dot product of electric field and area vector ds. So this is known as, this is the flux. So flux is nothing but dot product of electric field vector and the area vector, which is perpendicular to a small element ds. Now we shall go with the definition of electric flux. Electric flux is the total number of electric field lines or lines of force passing normally through any area placed in an electric field. This is the definition of electric flux. Electric flux is the total number of electric field lines passing normally through any area placed in an electric field. If any area is placed in an electric field which is directed normally to it, then the area vector, then E's direction is normal to it, and area vector also directed along normal to this area. So here the theta becomes 0 degrees. So here the flux phi E becomes E ds cos 0, which is nothing but E ds. Now if the electric field, as we say earlier, electric field passing through this direction and area vector direction, that is ds is along this, then the component of E field, if this is E vector, component of E, normal component of E along ds is theta, E cos theta. So for this, the first might be E ds cos theta. Theta is the angle between E and ds vector, and this is written as E dot ds. Okay, so this is the concept of electric fields. Sorry, electric flux. Now go with the Gauss theorem. So electric flux is measured by dot product of electric field vector and the area vector. Area vector is the vector normal to any surface area. The direction of surface area gives by the area vector. Now we have to write Gauss theorem. You know that the electric flux around any closed surface is equal to 1 by epsilon naught times of the total charge enclosed by the surface. This is Gauss law in electrostatics. The electric flux around any closed surface is equal to 1 by epsilon times of the total charge enclosed by the surface. If this is a surface which is enclosed a charge Q, then the total electric flux placed in an electric field E, then the total flux through this surface is written as closed integration S E dot ds must be equal to Q naught by epsilon naught. This is the famous Gauss law in electrostatics. Now, at first we prove this. How can we prove this? Then we can find out the electric field flux for any cylinder or cylindrical shape or any square placed in origin or at a distance from origin, the total electric flux. So we have to go with to proof of this theorem. So write down proof of Gauss law. To prove Gauss law, we have to take another definition which is called Gaussian surface. A Gaussian surface is an hypothetical or imaginary surface, any hypothetical imaginary surface around any closed charge, or we can say that the charge is enclosed by the surface, is called Gaussian surface. It is chosen as per requirement of the electric field. So, if we consider a Gaussian surface, spherical Gaussian surface, which is centered at Q of radius r, and if we take any small element ds, this is surface S. S is the Gaussian surface. Here the Gaussian surface is S. Gaussian surface is considered as S, which is in form of a sphere. It is a sphere of radius r. Now, if we take a small surface ds, then we know that the electric field, this distance is r because the radius is r. So that we know that the electric field at a distance r is given by 1 by 4 pi epsilon naught q divided by r. Now, what is the electric flux through this surface? Electric flux equal to phi of E through this surface is dot product of E dot ds. Now, as the charge is taken as positive, so the direction of electric flux is radially outward. Electric field, sorry, direction of electric field is radially outward. Also, the electric surface, also the surface area vector ds is along radially outward. So, electric field becomes parallel to area vector ds. So, here the angle becomes 0 degree because the direction of E and ds are parallel to each other. So, we can say that EDS, so E dot ds becomes only EDS. Now, the total flux, that is integration over S E dot ds, which becomes integration over S E ds, as this is a spherical surface, so the magnitude of E is constant over everywhere. Here E is constant, value of E is constant, here E is constant because of the symmetry of spherical surface. So we can take out E outside the integration. So E becomes ds. ds is the surface area of S, which is becomes 4 pi r square. So E multiplied by 4 pi r square. So this is the E into 4 pi r square is the total flux. Now put the value of E equal to 1 by 4 pi epsilon naught q by r square multiplied by area 4 pi r square. 4 pi cancel out, r cancel out, which becomes q divided by epsilon naught. That is close integration E dot ds becomes q by 4 pi epsilon naught, which is the proof of Gauss law. Okay. So in this way, we can define Gauss law and its proof. If you like my channel, subscribe for more such interesting videos for 11, 12 and both joint and neat. Now we go with numericals. Question number 1. If electric field is given by 3I cap plus 6J cap plus 4K cap in an area of 20 meter square, then find the flux in XZ plane, YZ. Or we can say that equal to 3I cap, 6J cap, 4K cap in an area, in an surface area of 20 meter square in YZ plane. Calculate phi. That is electric. Calculate what is the value of phi. So, if we consider this is x, y and z, so we can get the value of E becomes 3I cap plus 6J cap plus 4. Now, what is the direction of area vector? It is confined in YZ plane. That is, we know that the direction of area vector is perpendicular to the area of the element. So, if this is YZ plane, then its direction must be perpendicular to YZ plane. So, we can say that ds must be in x along x axis. So it is given by 20 I cap. Okay, because the this is the area which is lying in yz plane. So the area vector must be perpendicular to it. So it is along x axis. So it is given by, we know that the unit vector along x axis is I cap. So we can say that ds equal to 20 I cap. Now we calculate the flux I equal to close integration E dot ds. So you can get the dot product of 3 I cap plus 6 j cap plus 4 k cap dot 20. So for the dot product, we know that this component must be 0. So 60 Newton Coulomb minus 1 meter. Okay, this is the value of flux. Minus E dot ds Newton per Coulomb meter square. Newton per Coulomb meter square. Sorry. Okay. Then we go with the second numerical. I hope you understand it. Now we go with the question number 2. Let us consider a cylinder is placed in an uniform electric field E acting along this way. Calculate the total flux I due to charge Q of this cylinder. How can you solve this problem? So, for this cylinder, we can get 3 surfaces. One is this left surface, one is the right surface. If we take it as LS, that is left surface, and this is right surface, and this is curved surface. Okay, if this is the cylinder, this is left surface, this is right surface, and the middle portion is curved surface. Now, as we know that the direction of E cannot be changed, as it is given in the question that E is directed along this axis. Now, for the left surface, the area vector is perpendicular, and area vector always directed radially outwards, not inwards. It is perpendicular to the area, and it always acts radially outwards. So for this, for the left surface, the ds is directed along. Ds is directed along radially outwards. That is the opposite to E. So here theta becomes 180 degree for this case. For this surface, right surface, again the direction of E is direction of ds is radially outwards. So here theta becomes 0. And for this curved surface, the direction of the area vector is normal to it and radially outward. So direction of this vector is along upward. So this angle becomes 90 degree or pi by. Now we can get the total phi total if we say that integration of our s left surface, sorry, equation of left surface E ds cos 180 plus integration of our curved surface E ds cos pi by 2 plus integration of our right surface, that is E ds cos 0. Now cos 180 is minus 1, so you can get minus E ds cos pi by 2 is 0, and this is plus E. So minus E ds plus ds is cancelled. The total flux is 0. So the total flux inside this cylinder is 0. So the total charge Q must be the phi into epsilon naught, because phi equal to Q by epsilon naught as per Gauss theorem. So if epsilon is 0, then the total charge is also 0. So here Q is also Okay, next we go with the third example. I always said that please don't skip my video. You can see it to the last portion. X, Y, Z. A square is situated this is a square as this is 0 comma 0 the origin and this a square is situated at a distance a from origin. All the side of this square is also a. A charge is situated inside this square. Find out the total flux phi. And here also said that E only electric field along Ex, Ey and Ez equal to Ex equal to alpha x to the power half. Ey is 0, Ez is 0. That is electric field direction of electric field is only along x axis. So what is the value of phi? So if we say that the electric field Ex is along this direction. So except these two surfaces, if we take the surface number 1 and 2, that is the upper surface and lower surface, the area vector is along this direction and electric field along this direction. For the both upper and lower surface, the electric flux is 0. Similarly, for this surface and the front surface of me, if we take this, that except these two surfaces, this surface and this surface, okay, so similar phase, this surface and this surface is the flux is 0. Again, this surface and this surface flux is 0. Only the two side surfaces, the flux is the electric field is parallel to area vector. So only if we set this and this, only we have electric field parallel to ds. Otherwise, the four surfaces, as we know, the cube has 6 surfaces. The other four surfaces, the total electric flux is 0 due to the perpendicular component. Now Ex equal to alpha. If we said that E right, that is the right side, alpha x to the power half. What is the value of x? A plus a, that is 2a. 2a to the power half. That is E right. And EL, that is for the left place, it is alpha x means a to the power half. Now what is the flux? If we take phi r, ER, BS, cos theta. Here ds is act along radially outward, so the cos is 0. So you can get ER, BS. Now what is the value of BS? ER, BS is the area of the square. That is a square. Area of this side, that is only a square, not the cube. Okay, only this side. The side is a square, so its area is 2a. Sorry, this side is a, not 2a. That is ER into a square. Then we can get phi r equal to the value of E is along rightward, but the area vector ds is along next one. So that here theta is becomes 1 into. So we can get minus EL a square. Minus EL a square. Here the value of alpha is said 800 Newton Coulomb inverse meter square. Alpha, the value of alpha is given. So the total flux phi, if you say total flux phi T equal to phi r plus phi L. That is, if we common a square, then er minus el. So a square, what is the value of er? You can say that er equal to alpha x to the power half, that is er equal to alpha 2a to the power half, alpha into 2a to the power half minus alpha a to the power half. Okay, so a square a to the power half coming from the bracket, alpha a to the power half, so alpha a to the power half you can say root 2 minus 1. Okay, so alpha a to the power 5 by 2 root 2 minus 1, alpha a to the power 5 by 2 root 2 minus 1. So we can get, put the value of alpha 800, a to the power 800 multiply a to the power 5 by 2 into root 2 minus 1. Now if the value of a is given 1, then this is 800 into root 2 minus 1, and for any arbitrary surface, if you get that, you can find out the value of the total flux phi. A is here, A is not given. If A is given, then put the value of A and total flux is find out by total flux. Okay, so in this way we can find out the electric field. If you say that the total charge, then total charge is the total phi multiplied by permittivity of this space, 8.854 into 10 to the minus 12. So you can get the total charge inside. So Gauss law is very important for the class 12 exam, NEET or JEE exam. In the next day we can deal with the application of Gauss law and its numericals. Okay, if you like my video, please subscribe it and don't skip. I say it again and again that don't skip, because there is a lot of surprise, lot of new learning thing at the end of the video we will get. Okay, so for the today